Hey team, we're back for week 2. I think most of you did okay with week 1. I had a few people hit me up with questions and Zoom videos, and we had a great time. So if you need anything from week 1, let me know. I'm here for you. Hopefully you've got your Unit 1 test done if you're watching this, because you should do Unit 1 test before you watch this. We are starting on Unit 4, I guess, because now we're on term 2, but Unit 5 is beginning with these notes. So we have 2 units left. We're not going to do like a ton of Unit 6. So this is the last major stuff for Calc. So here we go. Here goes nothing. Unit 5, first stuff that we're going to talk about is sigma notation. You may or may not have seen this in college algebra. If you did, this should be a nice little refresher. If you didn't, that's okay. No big deal. Sigma notation is that big E looking thing, and it just means we want to add everything. That's all it means. Add all the stuff. And the bottom number is the number you're starting with, and the top number is the number you're ending with. You're going from that to that, and you're plugging those in to the equation over here. That's what that means. So we usually say that's the index, whatever your variable is, and so then your index starts with that and goes to that. So let's try some examples. So we're going to look at some examples in kind of like a table. I'm going to give you the sigma, and then we're going to write out the sum, and then we're going to see what the answer is. So our first example is k equals 1 to 5 of k. So that means we're plugging in 1 through 5 for k, and then adding them up. So the written out sum would be 1 plus 2 plus 3 plus 4 plus 5. Because if I plug in 1 for k, it's just 1. If I plug in 2, it's just 2. And we want to add them together. So our answer, our value, is 1 plus 2 plus 3 plus 4 plus 5, which is 15. Cool, good, happy. Example 2 is a little trickier. We want from 1 to 2 of k over k plus 1. So we plug in 1 for k, and we plug in 2 for k. So if I plug in 1, I get 1 over 1 plus 1. Plus, I plug in 2, I get 2 over 2 plus 1. So that's actually 1/2 plus 2/3. So final answer is 7/6. Because 1/2 is 3/6, 2/3 is 4/6, 3 plus 4 is 7/6. Cool. One more. K equals 4 to 5 of k squared over k minus 1. So we're plugging in 4 and we're ending with 5. So if I plug in 4, I get 4 squared over 4 minus 1. If I plug in 5, I get 5 squared over 5 minus 1. So that would be 16 over 3 and 25 over 4. And if I add those together, get a common denominator, do all that, I end up with 139 over 12. Everybody knows that. So that's kind of how sigma notation works. You plug in what you start with and keep going until you get to the top number, and then you add up what you got. All right. Another example. We can actually do this backwards as well. I have the sum 1 plus 3 plus 5 plus 7 plus 9, and I want to write that in sigma notation. But you could do this a million different ways. It all depends on what you start and what you end with. So you could have a ton of possible answers. You could say k equals 0 and then end with 4 and say that's 2k plus 1. 2 times 0 plus 1 would be 1. 2 times 1 is 2 plus 1 would be 3, and so on until you get to 2 times 4 is 8 plus 1 is 9. Or instead of doing plus 1, you could do minus 1, but then you'd have to start with 1 to get your 1 that you want to start with and end with 5 to get your 9. Or you could say 2k minus 3 and go from 2 to 6 or whatever. But since we're skipping every other number, that's why you've got to do a 2k and then either add 1 or subtract 1 because it's odds and not evens. If it was like 2, 4, 6, 8, I could just do 2k and say go from 1 to whatever. So that's kind of how that works. All right, so that's it for sigma notation. We're also going to do, this is actually 5.3. We don't do 5.1 because it's stupid and I hate it. And we kind of skipped 4.8 because 4.8 and 5.3 are pretty much the same thing. So a function is an antiderivative of f on an interval I if the derivative of x equals the original function f for all x in I. So there's a whole list of antiderivative fun facts, and normally I would print this out for you in color and laminate it for you, but we didn't quite get to that before we were sent home for the year. So I'm going to attach this on Classroom so that you have your own copy, because this is going to be like the most helpful thing for the rest of the year. So if you have a function of like x to the nth power, the antiderivative, here's what you do. You put your power out front, add 1 to it, and put it under 1. And then that's also your new power. So if you had like x to the third, the antiderivative would be 1/4 x to the fourth. Add 1 to it, and then make that fraction out front. You can see all the different rules here that we're going to use for the rest of this chapter. So I'm going to refer to your antiderivative sheet this week, next week, probably every week after that. So if you want to like write it down, print it off, whatever, you're going to want that sheet that I'm going to attach to Classroom. Important stuff. Why is it important? Because antiderivatives come into play when we do integrals. Integrals are going to be what we talk about this whole unit. So the collection of all antiderivatives for f is called the indefinite integral for f with respect to x, and we use this kind of S-looking shape, f of x dx. Dx just tells us what we're finding the antiderivative with respect to. And so if there's no little numbers, that's what we call an indefinite integral. What we're going to talk about this week is definite integrals. So definite integrals has what we call limits of integration. It has numbers on the bottom and the top. So you have your integral sign, a number down here, that's your lower limit of integration, a number up here, that's your upper limit of integration, and then your function, that's the integrand, and then your dx, which is telling you the variable of integration. And so what that means is the integral of f of x dx from a to b. All right, that's a lot. What's it mean? Well, we get to use some fun facts to figure these out. We have the order of integration. So if it goes from b to a instead of a to b, you just make it negative to flip them upside down. If you have the same number on the bottom and the top, your answer is 0. If you have a number on the inside, just a constant value, you can put it outside. If you're adding or subtracting two functions and you have the same numbers on the bottom and the top, you can split them apart or put them together. If you have the same number on top of one and on bottom of the other of the same equation, you can put them together. You can like get rid of that number. So a to b and then b to c is the same as a to c. The minimum maximum inequality says if f has a maximum value of max f and a minimum value of min f on AB, then the minimum times b minus a is less than or equal to the integral from a to b is less than or equal to the maximum times b minus a. So the integral is somewhere in between the minimum and the maximum times b minus a. And domination. If f is greater than g, so your function f is bigger or equal to g on a to b, then the integral from a to b is bigger than the integral from a to b. And if the integral of f is positive, or if f itself is positive, then its integral is going to be positive. Just some fun facts for you. Why do we care? Well, we're going to get problems that look like this. Suppose that the integral from -1 to 1 of f is 5. The integral from 1 to 4 of f is -2. And the integral from -1 to 1 of h is 7. We're going to do 3 examples. I want the integral from 4 to 1 of f, the integral from -1 to 1 of 2f plus 3h, and the integral from -1 to 4 of f. So let's look at letter A. I want the integral from 4 to 1 of f of x. Well, I know up here the integral from 1 to 4 is -2. And that very first fun fact on the last slide said if we want to change the order, we just put a negative out front. So that's what I'm going to do. I'm going to say, okay, instead of saying from 4 to 1, that's -1 to 4. Well, I know 1 to 4 is the same as -2. So that means it's -2. So my answer is just 2. All right, letter B. 2f of x plus 3h of x from -1 to 1. Well, I've got this guy here, and I've got this guy here. So I can put the 2 out front. I can split it into 2 separate integrals, and then I can put the 3 out front. So that's like 2 integral -1 to 1 of f plus 3 integral -1 to 1 of h. Well, then I know that -1 to 1 of f is 5, and I know -1 to 1 of h is 7. So that's 2 times 5 plus 3 times 7, which is 10 plus 21, which is 31. So you're just plugging stuff in, really. The last one, -1 to 4. Well, I know -1 to 1, and I know 1 to 4. So I can just add those, right? -1 to 1 plus 1 to 4. So that's 5 plus -2, which is 3. So that's how those work. You've got to kind of find what you know and figure out how you can use it to solve them. And that's it. You are done with week 2. Make sure you took your test, and you have, I think, 10 problems on your week 2 homework. Let me know if you need anything. Let me know if you have any questions. Let me know if you found any sweet shows on Netflix. I watched Tiger King. We can talk about it. I'm obsessed. And yeah, that's pretty much it. Have a good week. Do your best. Let me know what you need for help.